The basis of today's lesson is common logs and natural log functions, rewriting in terms of exponential into logarithmic and logarithmic into exponential. If we have the inverse function of the exponential function 10 to the x, it is known as the common logarithmic function. Here, we want to rewrite this exponential function in terms of a log. So when you rewrite in terms of a log, the first thing you do is write the word log. Your b is your base. You will take the log of n and set it equal to x. This is going from exponential form to logarithmic form. When you're going from logarithmic to exponential form, this creates a snail in the counterclockwise motion where b is your base, x is your exponent, and that will be equal to n. These two are equal to each other as they are inverses provided they are written in the correct form. This is read as log base b of x, not log b, log base b. And the functions b to the x and log base b to the x are inverses if and only if you rewrite log base b of v to the u in the correct notation where b to the u power is equal to v. We're going to rewrite the logarithmic function into exponential form. Again, remember this creates a snail, so this would be 3 to the 4th power is equal to 81. These two are inverses because 3 to the 4th power is equal to 81. If by chance you rewrote this incorrectly as 4 to the 3rd power is equal to 81, this is not a true statement, therefore you would know that you wrote it incorrectly. Rewriting b, 1/2 to the negative 3rd power is equal to 8, creating the snail. Rewriting c, 8 squared is equal to 64. These are all true statements, therefore providing the inverse function from logarithmic to exponential. You must also rewrite from exponential to logarithmic. Once it says rewrite into logarithmic form, the first thing you do is write the word log. Your base is 7. Okay? Then this comes next because you're rewriting and creating the snail of 1 over 343 is equal to negative 3. Creating the snail again like this. This comes first, this comes second, this comes third. It is log base 64 of 4 is equal to 1/3. Lastly, again, first, second, third, log base 2/3 of 4/9 is equal to 2. All you're doing is rewriting, showing that these are inverses. If you are asked to evaluate without a calculator, rewriting logarithmic into exponential, you would then be able to solve using the values on the first page of your homework packet that you were told you had to remember. First of all, set this equal to x, make it an equation. Rewrite it, creating the snail. 2 to the x power is equal to 16. You ask yourself 2 to what power is 16? You should know that this value is 4. Again, set the expression equal to x, rewrite. 1/3 to the x power is equal to 9. When you are going from a base that is to some unknown exponent to a whole number, fraction to a whole number, that means your exponent must be negative. More specifically, negative 2 because 3 squared is 9. If you are going from a bigger number to a smaller number, your answer would be a fraction because you would have to take a root. In the case of this last problem, let's reflect back on the graph of a logarithmic function. If I were to sketch log base 5 of x, the graph would look something like this. It is just a sketch of the parent function. In this case, the domain of this function is 0 to infinity, meaning your x values go from 0 to infinity where 0 is not included. Here, we're stating that our value is negative 25. Negative 25 does not fall within this domain, therefore this is not possible. And as a general rule, you cannot take logs of negative numbers. This is the exact reason why rewriting the log functions in exponential notation and then solving is a two-step process. First, you rewrite using the snail that I told you. 5 cubed is equal to x. Evaluate 5 cubed. 5 to the third power is 125. You're done. Rewriting. This would be 6 to the x is equal to 1. Any number to what power gives you 1? 0.